Okay, today we're going to do 5.5 notes with the power rule. So we are going to find the derivative of a function using the power rule. This is the shortcut to the very long process that we did in the previous lesson. Okay, the power rule says to find the derivative of a function f with a term with the coefficient a and the variable x to a power n. All you have to do is multiply the power n times the coefficient a, so a times n, and then it's the variable to the exponent n minus 1. You just take 1 away from the exponent. So for example, we have f of x equals x cubed. To find the derivative of f of x, remember that's the symbol for derivative, we're going to multiply the exponent to the number in front. So this is 3 times 1, which is 3. And then we drop the exponent by 1, so instead of x cubed, it's x squared. And that is the derivative. To find the derivative of g of x, it's g prime of x equals 2 times 1 in the front was 2. Dropping the power of x squared by 1, it is x. Over here, the exponent is 1 times negative 4 is negative 4. If you drop the power by 1, it becomes x to the 0 power, which is 1. So the variable goes away. So that is your derivative. The constant rule is for when you're finding the derivative of a number. Notice the exponent is 0. So you would do 0 times whatever number, and you would get 0. So the derivative of any constant is 0. So in our example, finding the derivative of f of x equals 3. So the derivative of f of x is 0 x's times 3, so 0 times 3, which is 0. So number 1, find the derivative of each function using the power rule. So for f of x equals x to the 6th power, we're taking the derivative of f of x equals, multiply the exponent to the coefficient in front, so 6 times 1 is 6, and then drop the power by 1. So instead of x to the 6th, it's x to the 5th. And that's a derivative. To find the derivative of g of x, you're going to do it to each term. So it's 2 times 1, which is 2. Drop the power by 1, x. 1 times negative 4 is negative 4. Drop the power by 1, so this is x to the 0, which goes away. And then the derivative of the 2 is 0 times 2, because there's 0 x's times 2. That goes away. So this is your derivative. For h of x, we're going to do it to each term. So it's h prime of x equals 4 times 2 is 8. Drop the power by 1, so we have x cubed. 3 times negative 7 is negative 21. Drop the power by 1, so if this is x cubed, it's x squared. 2 times 12 is 24. Dropping the power by 1, it's x. 1x times negative 8 is negative 8. This becomes x to the 0 power, which goes away. And then negative 10 times 0 x's goes away. So that is our derivative. Number 2, simplify the original function and then find the derivative of each function using the power rule. So for a, we have to distribute this x cubed into the parentheses before we can find the derivative. So to multiply this through, x cubed times x squared is x to the 5th. X cubed times 5 is 5x cubed. Once you've simplified this, now we can find the derivative using the power rule. So 5 times 1 is 5. Drop the power by 1, it's x to the 4th. 3 times 5 is 15. Drop the power by 1, it's x squared. So that is the derivative. We have to simplify by squaring x squared plus 4. So you can either do the box method or you can write it out twice and FOIL. So we do x squared times x squared, which is x to the 4th. X squared times 4 is 4x squared. 4 times x squared is 4x squared. And 4 times 4 is 16. Notice we can combine the like terms. So this simplifies to x to the 4th plus 8x squared plus 16. So now we can find the derivative of the function. So 4 times 1 is 4. Drop the power by 1, it's x cubed. 2 times 8 is 16. Drop the power by 1, it's x. Over here there are 0 x's. 0 times 16 is 0. So that is your derivative. This one, put a little star by, it's on the test, and it's a little tricky. We have to rewrite this without the x squared being in the denominator. To do that, we're going to use negative exponents. So 3 over x squared is equivalent to 3 times x to the negative 2 power. If you recall, the negative exponent makes it flip to the bottom of the fraction. So these are equivalent. Now I can find the derivative. So it's negative 2 times 3 is negative 6. And when I drop the power by 1, I'm subtracting 1 from the exponent. So negative 2, drop the power by 1, that makes it x to the negative 3. Please note you cannot leave your answer with a negative exponent. So now we can move this exponent to the denominator to make it positive. So this is going to make the derivative negative 6 over x to the positive 3.